this video, we're going to look at how we can rationalize monomial denominators. It is considered bad practice in math to have a radical in the denominator of a fraction. And so we will want to multiply the fraction by something, same thing numerator and denominator, to clear the radical out. In this first example, we've got the square root of 6 over the square root of 5, and the problem is that we have a square root in the denominator of a fraction. The way we will clear it is we will identify the number of additional factors we will need to clear the radical. With the square root, we have an index of 2, meaning we need 2 of any factors to clear that radical. So we'll introduce extra factors under a square root. We already have 5 under the radical. We need a total of 2, so we'll introduce one more 5 under the radical. Doing the same thing in the numerator and denominator. In the numerator, 6 times 5 gives us the square root of 30. In the denominator now, we have 2 5s under the radical, so those can come out as a single 5 outside of the radical. With nothing left inside the radical, we end up with root 30 over 5. We'll always want to check to see if we can reduce the 30. Factors to 3 times 10, and 10 is 2 times 5. And because there's no pairs, the 30 can't reduce. So our final answer, rationalized denominator, is root 30 over 5. Let's try another example with a higher index. Here we have an index of 4. This means we need 4 of any factor in order to clear it out of the radical. We already have a single 2 under a 4th root, so we'll do another 4th root, and we need 3 more 2's. 2 times 2 times 2. Same thing in the numerator. To clear a 4th root, we needed 1, 2, 3, 4 2's. So in the numerator, we added 3 more 2's, or multiplied by 3 more 2's. And now we have 3 times the 4th root of 11 times 2 times 2 times 2, which is 88, over, we now have 1, 2, 3, 4's under a 4th root. That means we can pull it out with nothing left in the radical. We get this final answer of 3 times the 4th root of 88, whoops, not over 4, sorry. We're pulling a 2 out. We have 4 2's, so we pull a single 2 out over 2. Let's try one more example, rationalizing the denominator by introducing any extra factors we need. Again, here we've got a cubed root of 25 in the denominator, and we don't like to have radicals in the denominator. One thing you may notice about the 25, however, is that we can factor the 25. 25 is 5 times 5, which means we already have 2 5's under the cube root. So now, underneath our cube root, how many more 5's do we need? We already have 2. With one more 5 will give us a total of 3. And we'll do the same thing in the numerator and denominator. In the numerator, we have 4 times the cube root of 10. In the denominator, there's a 7 in front of everything. And then under the radicals, we have 1, 2, 3 5's under a cube root, so one of those 5's can come out. Nothing left under a radical. And all we need to do to finish this problem now is multiply that 7 times 5 together. Our final answer is 4 times the cube root of 10 over 35. To rationalize our denominators, to get the radical out of the denominator, what we will do is find the number of additional factors we need to pull the numbers, or to pull the factors, all out of the radical.